Hi folks. Um, so thank you all for coming. Um, as you have heard, I'm Sherin Thomas. I'm working in an early stage startup called Tensor. So I'm going to talk about RedisAI, which is a tool that we have been developing along in collaboration with RedisLabs, the creators or like the home for Redis, the database, if you have heard. So we built RedisAI with a couple of agendas in our mind. So I'm going to run you through what we were thinking and why should you probably try it out and why is it good for production deployment. So it's going to be a walkthrough, and right after the lunch, you have a tutorial. So whatever I'm going to run you through here will be doing hands-on or like at least going through a Jupyter notebook and see how things actually work. So feel free to join. Um, so the things that you're gonna see here, you can try it out in the next session. Okay. So, like I said, I'm working in TensorWork. It's a 3 months old company. We are building the utilities required for software 2.0, which is defined by Andre Karpathy like very recently. So I'm known as HH2nd in internet. This is my tag name. You can find me in Twitter, LinkedIn, GitHub, like my website, wherever. I'm going to tweet this slide right after the talk. And so if you're attending the tutorial, you probably have to go and get the slide. And there are a couple of links that you have to download before you come for the tutorial. So I'm a senior software architect at TensorWork. I created TuringNetwork.ai. It's again a super early stage product for interpretability of for finding or for interpretation of your neural network models. I co-organize Deep Learning Bangalore, the deep learning meetup of Bangalore. So this is what I've mentioned as software 2.0. So like what we had earlier as in software 1.0, there's an alternative in software 2.0 world. So source code is being seen as the data. Like everything that you had in software 1.0, you have a alternative in the data defined software era. So I'm going to specifically talk about VM and the deep learning runtime, which is this RedisAI thing is about. So at TensorWork, we decided to take this up because software 2.0 is a completely different world. You need new toolkits to handle the things in software 2.0. You probably won't be able to use the existing toolkits that you have for software 1.0. But we haven't realized this so far. So we are still using the old system that we have for which we have developed for software 1.0. So we found this problem with the new data-defined software era. So we decided that we have to do something about it, and that's what all about TensorWork. So this is our suite. So this is our plan. This is what we have planned about the suite. So we have developed Hangar and RedisAI already. Hangar is basically Git for your data, and RedisAI is a production runtime. The first three can be used for development, and the last RedisAI is for production deployment. So Hangar is open source, Apache 2 licensed. You can install it, pip install Hangar, and you can basically do branching, time travel, push data to it, pull data from it. So a couple of problems that we have when we deal with data is you probably have like 15-20 dB of data, and you don't need that in your laptop to prototype a model, but you essentially have to end up downloading the whole 15 dB because there's another way. So we solved that with partial cloning, and as of now, as far as I know, there is no existing system that could do version controlling for your data exactly the way we want. So that's why we developed Hangar. You should go and check it out. We have developed data loaders for popular deep learning frameworks and import and export utilities, which import the different data types. So if you have like a folder full of images and you want to export that to your Hangar version controlling system, you can do with one-liner. So there is a Python package, so you can interact with your data not just from the command line but also from inside your program. The benefit is you are going to get a NumPy array back from your data store instead of you writing pipelines to convert your data to some form where you can exploit the data or like run through the data for training or whatever. You can do all the operations like checkout, merge, branching, whatever you want, commit from Python itself. So it's 0.1.1 now, but we are releasing 0.2 this week with like a lot of good features. There's like a pretty good documentation available in RTD, and this is a website. This is a GitHub. You should go and check it out and probably give us a star if you like it. We really appreciate it. So yeah, with that, we're gonna start the actual talk of today, Redis AI. So before jumping in, we'll look into what do we already have, right? So if you have already worked with deep learning, so it's like a 101 of deep learning. You will have neural networks, you have tensors, you have operations between tensors. So you could do mathematical operations. You could connect all these linear operations and non-linear operations, the activations function together to make a neural network, and you can train with that with optimization functions, and you end up having like a really good model, hopefully. And till then, it's fine, right? So this is a mature part of data-defined software era. We have everything we need for. So apparently it's not working. Sorry. So we have deep learning frameworks, which is well built. Couple of deep learning frameworks. All of them has its plus points, and a lot of big names in the industry are already using it. So this is, as I said, is a mature part of data-defined software era. And maybe we'll just stop right there and go back to traditional machine learning world. And even then, we have like really mature ecosystem of tools, frameworks, and like really good algorithms that we could use for the data set that you have. So this is cool. But what do we do next? You have got enough data, you have got enough compute, you have got really good framework or software toolkits. You can train your data. What's next? So these are the existing production strategies that we have right now. So what do you guys normally do? Like if you are like an early stage company or like a small company, you probably don't invest a lot into the DevOps side of it. Instead, you probably write a Flask Django wrapper around your model and deploy that to production, correct? Which is good, but what if you want to scale? What if your server goes down? How would you know? Or like all this problem that you're gonna have with the tradition or the good old API system that you're gonna make. Maybe you can go and try and use some cloud providers like SageMaker, or like some other cloud providers, or you can use some advanced runtime like TF serving or MXNet model server MMS, or like Clipper from Berkeley and TensorRT from NVIDIA. Or you can make your own bespoke solution with writing a C++ runtime by yourself. And for scaling it up, you're gonna use Kubernetes, and like let Kubernetes takes care of the scale. So couple of problems with the approach that we already have. So these are the production requirements that I think are relevant when you try to push your models to production. It has to fit your technology stack, right? It's not when I said technology stack, I did not mean development stack, but the technology stack. So I've met a person who had like the whole system in Erlang, but he had to introduce Python to his production stack just because he wanted to use deep learning. I mean, he could have used C or C++, but he ended up pushing Python to his production stack, which he doesn't want, but he had to. It has to be simple. It has to run anywhere, so you might have to run it on a GPU machine. You might have to run it on a Raspberry Pi. You might have to run it on like your laptop, or like a normal EC2 instance. It has to limit the moving parts. You should not have like a lot of things to worry about when you push things to production. You should not have a lot of we try to avoid the moving data as much as possible. So one instance I could bring up is, if let's say your data is being saved in an S3 storage, and if you can run your model right besides the data, you can reduce the cost of data transfer a lot, right? So that's another requirement that you might gonna have. and efficient use of resource. So these were a couple of points that we have in front of us when we start brainstorming about a runtime, and we end up approaching Redis. So how many of you guys doesn't know about Redis? Oh, okay. At least heard about Redis? No? Okay. Cool. So Redis is an in-memory database. It's gonna save or like serve your data from memory, and hence it's super fast. But it processes the data, or it writes the data to the disk, so that if the database crashes, you don't lose your data. It has couple of fundamental data types like list, array, hash, etc. You can do replication and partitioning. So if you have like a master slave setup, you can almost always be sure that your service will be up, because if master goes down, Redis will make sure one of your slave becomes master. So you can do partitioning with cluster. You have like a multi-cluster setup, and you can shard your data, redirect your request to multiple machines, and make sure you are scaling up. Redis is a decade-old product, so it has clients in almost all the popular languages. Most probably, you will never end up in a language that does not have a Redis client. So that's cool. From 5.0 version of Redis onwards, you can write modules. So if you have an idea that you think you can plug into Redis and exploit all these benefits of Redis, you can essentially do that. You can write a module and plug that into Redis itself. And you can add, when I say you can make a module, you can add new commands to Redis. You can add new data types to Redis by writing a module and then plug it into Redis. And that's exactly what we did with RedisAI. So it's a Redis module, like I said, providing a tensor as a data type. So Redis by default does not have a tensor data type. We have made a tensor data type and deep learning model execution runtimes on CPU, GPU. TPU is upcoming, and a couple of devices that some of our users requested, some of hardware devices. So it's basically, RedisAI is basically turning your Redis database into a fully fledged deep learning runtime. And you don't really have to worry about installing a database for running your production runtime or your models, because Redis is like an extremely lightweight process. So it's not going to eat up your resources. So basically converting your database to a fully fledged deep learning runtime while still being Redis. So this is a repository. Again, if you like the product, go ahead and give us a star. So the GitHub is being actively, the product is being actively developed. The general availability is next month in August. So post that, we will release the list of companies using it in production, like more stable, more documentation, etc. So yeah, so this is a pictorial representation of what is going to be in RedisAI. So RedisAI has like a Redis database in the middle, and we have made the tensor data types. And we have made PyTorch, TensorFlow, and ONNX as the backend of Redis for the runtime. So one of the main problem that you're gonna have if you are a deep learning company is you maybe get a pre-trained TensorFlow model or a PyTorch model or a model from some framework. But since your stack is only on, let's say, TensorFlow, you either have to convert your model to TensorFlow or like rewrite the whole stuff and retrain it. If let's say you take the risk and going to use that pre-trained model that you have got, you end up having have to manage multiple frameworks and multiple way of deploying it. For example, if you have a TensorFlow model, you're probably using TF serving for deployment. And let's say you found a PyTorch model, how will you deploy it, right? You probably have to find another solution to deploy it. But RedisAI is solving that problem by giving you 3 backends. So you have a PyTorch, TensorFlow, and ONNX. And through ONNX, you can convert almost all the popular models written in all the popular frameworks to ONNX and run on that backend. It's not just for deep learning. That's a highlight. You can even convert scikit-learn, Spark, XGBoost, or whatever traditional machine learning model that you have to ONNX and run it on ONNX-Runtime. Plus, it's on GPU, so you can even run your scikit-learn model on GPU, which is not something that we could do easily till now. So GPU, CPU, and as I said, TPU is upcoming. Something called TorchScript. I'll be defining that in a bit. So the idea is it's like a subset of Python language, but it's not running in Python interpreter. It's running on a highly efficient C interpreter, but for getting that performance, you don't really have to learn another language. You can write your Python function and let Redis takes care of that, take that code and run on a highly efficient C runtime. Replicas, master and slave. Okay, so this is a simple architecture of Redis AI. So you have like a queue. So if you have like 100 requests coming in a second, your system will not fail. Instead, we put that 100 requests in a queue, and there is another thread running, which pulls the data, data or model, whatever from the queue, and execute in a separate thread. So you don't end up having your server blocking your request. Where to get it? The easiest method is definitely Docker. You install Docker and do this Docker run on that particular port. With RedisAI image, the server will be up in like very easily. You don't have to do anything else. Or if you want to build it from scratch, which is probably what you want to do in production, you can, it's like 5 or 6 lines of commands. It's not like a 2 days job for deploying your deep learning model to a highly efficient production system. So I'm going to introduce a couple of APIs of RedisAI. So for a deep learning runtime, what you essentially need, right? It's not a training. It's not going to let you train. So it's just for executing the models. You should be able to send your tensors to the runtime. You should be able to run it and get the tensors back, right? 3 operations. So you essentially have tensor set and tensor get. So if you don't know already Redis is a key value store, as I said. So everything that you're going to send to Redis is going to associate to a key, right? So you say this is the key I want to save this model or this data with. So with tensor set, you say foo is my key name, and I want to save this data of type float, shape 2 by 2, and 1, 2, 3, 4 as value on that key, foo key, right? You don't have to pass. So if your input is an image of size, like 141, 416, 4163, that's going to be a huge array. You don't have to pass like values. You can convert it to a byte array and pass that byte array. Redis AI will still take that. You can get the tensors back with the same key value. So if you know the key, you can do tensor get of that key and you get the value back. So the tensor structure is basically built on top of DLPack. DLPack is this interoperability system, interoperability standard that different companies have made to store the tensors. So if your tensor is DLPack, converting your DLPack tensor to, let's say, PyTorch tensor is extremely cost efficient because you're not going to copy the memory. The data would be exactly same, but you're going to change this DL context and say whatever is required for PyTorch to understand the data inside this the memory, right? So this is what we use, and because of this, we can plug multiple frameworks into a single pipeline. So if you have like a TensorFlow model, then a PyTorch model, you can plug this two together in a single pipeline, and the TensorFlow tensor will be moved to a PyTorch tensor, and this happens extremely efficiently because tensors are DLPack. Okay, so done with tensors, let's move on to model. So you do model set to set a model to Redis. This is how you send a model binary file to Redis and ask Redis to keep it. And you again definitely associate that with the name. Here that's ResNet 18, and you have to specify the backend and the device that you want to use. So in the case of TensorFlow, so if you have used TensorFlow before, you have to specify the input and output name when you do session.run, right? So similar to that, you have to pass input and output. That's only where Redis AI to know that what's the input and output node of your graph. Then if it's ONNX, similar to Torch. So that's model set, and this is model run command. You say this is the key where I have saved a model and I want to run that model, take this input, again, it's a key, the input that's associated with this input, in this key, and save the output to this key, right? Save the output to the key name bar. So when I do this, the model will be executed and the output will be saved on bar. Then I can do a tensor get on bar to get the data back, right? So this is what I skipped last time. So script is, like I said, it's a subset of Python language itself. So the benefit is, let's say you're making a image recognition system, right? And you almost always have to convert or like normalize your image before processing through your model. That's pre-processing. And then after the execution of a model, you get an output. It's probably a softmax. If it's an image classification model, then you have to convert that spanned array to like something else, basically a post-processing. So if you're, let's say, making a Flask server and you have like a model to do the prediction, what do you have to do, right? You have to write the logic in your Flask server. So you get an image, which is like a height into width into channel, a three-dimensional image, if it's color. Then you have to do the pre-processing in your Flask server. You get something from that pre-processing step. Then you send that to your model run. Model will be executed. You get a softmax output. Then you take that, you run that to another post-processing function that you have written in Flask itself. Then you get a post-processing output. Then that is what is being sent back to the user, right? So how efficient would this be? Because one thing, pre-processing and post-processing running in Python, and it won't be able to use GPUs, and since it is in a Flask server, you don't really can scale it unless you use something like Kubernetes or something. But with the script, you write your Python function, and it can be in a text file. It just have to be a string. So this is a Python function that accepts 2 arguments and return a plus b. And then you tell RedisAI that do a script set, and this is my file name. Set that on GPU. Right? So RedisAI is going to take that function, compile it. Normally Python is interpreted language, so normally it's going to be interpreted at runtime. But RedisAI is going to compile it and save that optimized binary on that key. And when you send the data, it's going to run that function on GPU because you have set as GPU. So this essentially you can utilize to do the pre-processing and post-processing. So this is like a typical workflow. So you have an in key, you run that your pre-processing script, then you get an output, you run that to the model, and then you get the model output, you run that through the post-processing script, then you get the output key. So if you want to know more about the scripting, you can go to the TorchScript document. So essentially this is something that we have written on top of PyTorch, but as a user, for you, it doesn't have to do anything with PyTorch. You don't even have to import PyTorch on top of your code. So replication is possible with 2 mechanisms. One is master replica, which is also called as sentinel, and cluster. So the image is reverse. So this is sentinel image. So this is like a typical setup. Let's say you have a master node and a 3 slave node. Let's say your master node is going down. Redis automatically elects another slave as your master and then continue operation without you worrying about bringing up your master back. Master replica. So cluster, like you can shard your data. Redis will take care of redirecting the request to the required node. So this is a simple example that we have. So if you go to RedisAI example repo, you can see this code, the chatbot that we have developed. So a typical example is a auto encoder. So you have like an encoder and a decoder network. So you send a message to, so that's your master, you send a message to that. So there is a hidden state that's being changed here. Then there's a reply came, and who are you? Then, so that state, the hidden state, is going to be replicated. It's going to send to all the slaves so that the state of the master is being saved in all the slaves. Then suddenly the master going down, Redis elects another as master automatically. You don't have to worry about anything. Then send the next request to the new master. then you get the reply from the new master, and the state is being changed in the new master, which is going to be replicated to all the slaves. So this is an example repo, github.com/RedisAI/RedisAI-examples. So there are a couple of examples already there. You should check it out. And there's a Sentinel example which you can try out and see how this master replication works. Client libraries. So we have client libraries written in Java and RedisAI and Python. But Node and Go is upcoming. But a post note is, all the Redis clients will work work for you even if you're using RedisAI. But this packages that we have written is basically a convenient wrapper over the Redis client in that particular language. So even if you don't have like a specific RedisAI client for your language, you can essentially use a normal Redis client. Okay. So these are the advantages of RedisAI. So the chatbot example you have seen, right? So you have the hidden state. Again, in a normal Flask application, what will you have to do? You get a sentence, you convert that probably to indices, then send that indices to the your server or like your production runtime. Then you get a response back, and what that response is going to be an output indices and a hidden vector, right? The hidden vector keep the context. So you have to save this hidden vector because when the next time the user sends a sentence, you have to use this hidden vector to get the next prediction, right? So you have to save this somewhere. And normally people use Redis for that or Memcache for that. But since RedisAI is inside Redis itself, you don't have to really worry about that because after sending a sentence, you get a response back. You don't take the hidden vector back because you don't need it, right? You save that in a key in your Redis database. You only get the output. You process that output. When you get a next sentence, you send that next sentence to RedisAI and ask RedisAI to take the hidden vector that you have saved previously on some key, right? So you don't really have to transfer this hidden vector around, and that basically saves transfer cost. It's convenient. It's multi-backend and run on multiple devices. So as I said, supports TensorFlow, PyTorch, and ONNX, and through ONNX, bunch of other frameworks. So you can have like multiple models in multiple frameworks in your single pipeline. Traditional ML on GPU, like linear regression, decision tree, random forest. I don't think it was easy to run your traditional ML on GPU till now. So scripting is one of the biggest advantage as I see in RedisAI. You can do auto batching. So what is auto batching? So if you get like 500 requests together, like in a single second, you can batch it together and execute it together and get the response back with a typical easy to found production runtime. You can't really do that, but TF serving definitely helps you do that, but it's not a cakewalk to implement TF serving and auto batching in it. So high availability with Sentinel, you can do clustering, you can keep the stack short. What I meant by that is it's very likely that you're going to have Redis in your stack already. So if you have Redis in your stack, you are not introducing another toolkit for production deployment. Run everywhere where Redis runs. You can optimize the resources, and you can essentially use every toolkits available in Redis ecosystem. So for those who are attending the talk, you should get this repository that has the Jupyter notebook, and the model that we're going to use is a YOLO model, which is of like 250 MB in size. So this is the current state of RedisAI. There are a bunch of companies that we know using it in production, and a couple of things that's upcoming is one is DAG. DAG is a direct acyclic graph. So you probably have assumed. So if you want to run, let's say one instance now, what you have to do is you have to do a tensor set with your input first, then a model run with that tensor, then a tensor get to get the output back, like 3 commands to actually run the whole model thing, right? But with DAG, you can, instead of saving anything to a key, you save that to a volatile key. So this is basically wings, which we are saying that it's volatile, it's gonna fly. So you're gonna save that to a volatile key. then you can use that key in your next command, but it has to be inside your DAG scope. Right? So after the DAG scope, that in key is not valid. So it has to be, if it's inside your DAG scope, then you can use those keys, but you're not essentially writing to the Redis store. So you execute everything, and the end of the command, you write only the last key. You are skipping writing the intermediate values. So this escalates, the efficiency escalates in the diagram RO. RO is read-only. So you have like a master slave replica. Since it is read-only, you can execute all these commands in your slave, right? So here I'm not writing it to a key. Instead, I'm again writing it to a volatile key. Then after that, I'm gonna do a tensor get on that volatile key. So I'm gonna get the data back on the last command, right? So all of this operation happens in a single diagram RO scope, and you get the data back after the scope. Since you're not writing anything to the Redis store, you can do this in your replicas. So again, DAG has another benefit. So if you have like let's say you're doing A/B testing, and you have like a TF model and a torch model. So for all the input, you're gonna run both TF and torch model. But since execution of these two models are not dependent, you can do this parallelly. And RedisAI analyzes your commands, and it finds there are some script that I can run independently, so it'll run parallelly on different devices if you have more than one device. You don't have to take care of that. So far, whatever I've said is a blocking client call. So if you're making a call to run a model, the client will be blocked and wait for the output. But if you have like diagram async, then the client will return the control right after the execution with a ID which you can be used to fetch the result later. So normally deep learning execution are costly. It might take like more time. So your client does not have to wait for that to complete. So there is something else also coming in diagram, which is streams. So if you have like a constant, real-time input coming through a stream or something, you can set an input stream and you can set an output stream. The input keeps on coming, the model keeps on running, and the output keeps on pushing to the output stream. Auto batching, as I said, you batch the data together and run it together, which is efficient. So this is something that we are working on right now. It's probably going to be released in 1 or 2 days. So if you have like only a Torch model, you don't have to load TensorFlow and ONNX as a backend. You just have to load Torch. You can do monitoring on your Redis system with AI.info. So RedisAI system with AI.info. So if you want to analyze how it's happening, then we can do that. So this is RedisAI Enterprise. We have like an enterprise version that has all the dashboards and stuff that we have pre-built, which is a paid version of RedisAI. So I've written a blog, RedisAI, so it's gonna run you through an example. So if you're not attending the tutorial, you could go back home and read this blog. This is gonna give you like a fairly good idea, hands-on, about how you should do things with RedisAI. So yeah, that's it. That's about it. I'm done with my talk. So we definitely appreciate your feedbacks. If you have feature requests, go back to your GitHub and raise requests, and yeah, of course, contributions.